Hi everyone, today we'll be talking about transformations with a quadratic graph, which what a transformation is, it's going to move the graph around from something called the parent function, which is your start graph. So your graph might go left, it might go right, it might go up, it might go down. It might get wider or more narrow, or it could flip upside down. But every single time when we graph transformations, we will have a start graph where we always start from, and that is called the parent function. Okay, which you guys did an activity in class where you already graphed the parent function, so you kind of already know some things about the parent function, but I'm just going to do a quick recap of the parent function. Okay, so for the parent function, we're always going to use the x values, -2, -1, 0, 1, and 2. It's always good to use a little bit of negative values and some positive values as well as 0 to give you a nice shape of your graph. Okay, and all you have to do to get the y values is to square all of your x's. And when you do that, you get this lovely U-shaped graph, which is called a parabola. And the vertex is at the origin. Okay, so also we talked about the domain and range for the parent function. So the domain, you ask yourself how far left and how far right your graph will go. Okay, so the domain pertains to the x values of the equation. Okay, so in a parabola, the graph, it doesn't look like it, but it will continue to get wider and wider. So both of these arrows will continually get wider, which means how far left will the parabola go? It will keep going for forever, as well as to the right. Since it gets wider and wider, it will continue on for forever. So you will end up using all the x values in the real number system, which means x is all real, which you can also use that, that little symbol notation I've taught you. I couldn't do it on my computer, that's why I just typed out x is all real. But remember, you can use the shortcut notation for saying x is all real numbers. And every time you have a parabola, your domain will always be all real numbers. Okay, now the range pertains to the y-axis, and you ask yourself, how low does the graph go, and how high does the graph go? Okay, so looking at how low it goes, well, the lowest y value on my graph is at the point 0, 0. And there is an actual point there, it's shaded in, which means the y's can equal that value. So it is equal to 0. And then you ask yourself, how high does the graph go? Well, these two arrows on the ends of your parabola means that the graph will continue on to infinity and beyond with Buzz Lightyear. It'll be great. Okay, so it's going to keep going up for forever. Okay, so are these values up here larger or smaller than 0? We have things like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5 billion. Okay, so are those numbers larger or smaller than 0? Holy hot dog. They are larger than 0. So that means for your range, the y values that work for your parent function of a parabola, y equals x squared, is where y is greater than or equal to 0. Okay, so when we start graphing the function, we're always going to start from that function. That will be our start graph. Okay, we're not going to be graphing them quite yet. Okay, but when we get there, we're always going to start with this graph. So it's something for you to look forward to. Okay, so also in class, you guys did a nifty activity where you guys found out that different parts of a quadratic equation affect the way the graph will move away from the parent function, which was super cool. You got to see your you got to see your graph like dance around. It was really awesome. Okay, so if you remember from the activity, the a value does some things to the graph, which the a value is the number right in front of your parenthesis. It's the very first thing you see after the equal sign, and it's right before your parenthesis. Okay, so if you ever have a negative a value, it will always reflect your graph over the x-axis, which just means it's going to flip upside down. Okay, if your a is greater than 1, if the absolute value is greater than 1, so basically, if it's not a fraction, which I know there's numbers greater than 1 that are fractions, but typically if it's not a fraction and it's larger than 1, okay, it will be a vertical stretch. So the graph will get more narrow. If you can kind of picture yourself grabbing the vertex and the two arrows and pulling them apart from each other vertically, it would stretch it out vertically and make it shrink to be more narrow. Okay, so, and then when a is a fraction, or in between 0 and 1, okay, it will be a vertical compression. So if you imagine yourself kind of compressing the vertex with the arrows and pushing it down, it will cause the graph to widen out. Okay, so again, negatives, flip it upside down. When it's not a fraction, it went running with Miss Long and lost some weight and it became more narrow. Okay, and then when it is a fraction, it sat on the couch for too long eating potato chips and gained a little weight and got wider. Okay, so when it's not a fraction, it will get wider. Okay, and sometimes with the a value, you can have a combo. Like you can have a negative that is also a fraction. So a values can also have two things going on at once, which is pretty cool. Okay, now the h value, that is the value that is added or subtracted to the x inside of the parenthesis. Okay, and that will move the graph left and right. But you have to think the opposite with the h value. Okay, whenever you see x minus an h value, usually when we see a minus sign, we think left, because when you head left on the x-axis, you get more negative. Well, you got to think the opposite. Okay, so when you have x minus h, it will actually go to the right h units. Okay, and if you have x plus h, I know the demon cats are going to tell you that it goes right, because when we think x plus a number, we think about a positive direction, which is to the right. But with the h value, you have to think the opposite. So when you have x plus 8, it will shift to the left, okay? H units. Okay, and lastly, the k value, this is the number outside of the parenthesis that is either added or subtracted on the very end of your equation. Okay, and you don't think the opposite with the k value, so be careful. When you have a plus k on the outside, that will tell you that your graph is moving up k units. If you have minus a k on the outside, that means your graph will move on down k units. Okay? So these are the different values that will affect your graph and cause it to move away from your parent function. And what's really cool, you guys will already know what's going to happen to your graph without graphing it. You're going to be like a math magician. You already know what's happening before you even see it happen. It's pretty cool. Okay, so we're going to be math magicians now and tackle examples 1 through 3. Okay, so what I want you to do is I want you to tell me, how will the graph move away from the parent function, or what is the transformation given what's given to you in the equation? Okay, so we're going to start with example 1. All we're doing, if you want to write a set of directions, I didn't include any because the demon cats got me. Okay, but all we're doing is stating the transformations. Okay, so when we do this, you guys, first of all, we need to know if the part of the equation that's been added to the parent function, which don't forget the parent function is just the x squared, so anything other than the x and the squared is going to be a transformation. Okay, so the first step we must know is the extra value in a, h, or k. So I see this x squared right now, so that has nothing to do with the transformation. It's this plus 2. Okay, so this plus 2 is added on to the very end of the equation. It's not in a parenthesis with the x. So what do you guys think? Is the 2 an a, h, or k? What do you guys think? Heavenly hamburger, you guys are on it. It would be a k value because it's added to the end. And since our k value is positive, that means it will move up, and since it's a positive 2, the graph will move up 2 spaces. So the transformation, the answer to example 1, is your graph will move up 2 spaces. So the transformation moves up 2 spaces. All right, this next one is going to be example 2. So again, we ignore the x and the square. Everything else is a transformation that will take your graph away from the parent function. It will cause it to move around. Okay, so this negative 1/2. Okay, let's look at this. All right, it's the number that's right after the equal sign. Okay, and it's right in front of the x squared. It's being multiplied to the x squared. So what do you guys think? Is it an a, an h, or a k? You guys are so smart. Okay, that negative 1/2 is an a value because the a value is right in front and it's multiplying to the x. Okay, now, there's actually going to be two things going on with A. I told you sometimes the A has a double transformation, so be careful. Okay, when A is negative, it's a negative 1/2. Do you guys remember what happens when A is negative? Of course you do. When A is negative, it will reflect over the x-axis. Also, the A value is a fraction, or in between 0 and 1, it's 1/2. So what happens when you have a value that's a fraction? It will be a vertical compression. So this graph will not only reflect, whoa, get a little crazy here. Sorry guys. Not only will your graph reflect over the x-axis, it will also vertically compress or get a little bit wider. Okay, so this one has two transformations in one, which is pretty cool. So again, the transformation, it reflects over the x-axis and is a vertical compression by a factor of 1/2. So that means it'll be half the height that it was, which will make it flatten out and get a little bit wider. Okay, now lastly, I see the x and the square. So the only thing that's new in my equation is the -1. Okay, which I know that arrow is really hard to see, but there's an arrow there. Okay, so the -1 is added or subtracted to the x, which currently is being subtracted. Which value is either added or subtracted to the x value in the parenthesis? That would be an h. Look at that. Okay, so it's an h value, and if you have x minus an h, okay, which I have that right here, x -1, what will happen to your graph? You guys are too cool for school. That would be going to the right. Okay, and since it's -1, that means it's going to the right one space. So this graph is going to move to the right one space. Well, there you go. You have examples 1, 2, and 3. The next set of examples, we're going to reverse this process. What will happen is I'm going to give you the transformations, and you'll have to build your own lovely quadratic equations. So get excited for the next example problems in a little bit.